Hello class! Today, we will be discussing the polarity of molecules and its properties. The objective of this discussion is to define solubility, miscibility, and polarity, identify the different types of intermolecular forces of attraction, and explain how polarity of molecules relate to its properties. Last meeting, inexplain ko sa inyo na ang concept ng polarity ng molecules ay similar lang sa concept ng polarity ng magnets. Ang magnets ay may positive and negative pole. Ganon din ang battery, may positive and negative pole din yan. As well as the earth. So same lang dito ang molecules. May positive and negative poles din sila. The next word we are asked to define is solubility. So, solubility by definition is the ability of a solid substance to be dissolved in a given amount of solvent. So, pagkatunaw lang ni solid substance sa solvent ang pinag-uusapan natin dito. Solute yung natutunaw, solvent yung natutunaw. We have here an example. Sugar nilagay sa kape. We all know na pag hinalo natin yon, madidissolve ang sugar. The other one is salt nilagay sa tubig. So, salt is the solute and water is the solvent. Matutunaw ang asin pag nilagay sa tubig. That is the concept of solubility. Next, we have miscibility. It is the ability of two liquids to combine or mix in all portions, creating a homogeneous mixture. So, miscibility is basically dalawang liquids lang na pinaghalo to form a homogeneous mixture. So, paano natin malalaman kung homogeneous ang isang mixture? Masasabi natin na homogeneous ito kapag hindi mo na malalaman kung alin si liquid A or alin si liquid B kapag hinalo mo na ang dalawang ito. Meron tayong example ng miscibility dito. So, two liquids, water and alcohol. Nung kinumbine itong water and alcohol, and you get a sample of that mixture, hindi mo na masasabi kung alin ang tubig at alin ang alcohol doon. So, ganun si miscibility. Also, we have soy sauce and vinegar. When mixed together, you cannot determine anymore kung saan banda ang soy sauce at saan banda ang vinegar. There is a general rule that we should take note of about solubility and miscibility of molecular compounds. So, sabi dito, like dissolves like or like mixes with like. Ang ibig sabihin lang nito class, ang polar substance ay pwede lang ma-dissolve or maihalo sa kapwa niya polar substance. Likewise, ang non-polar substance ay pwede lang ma-dissolve or maihalo sa kapwa niya non-polar substance. In our previous discussion, we learned about the intramolecular forces of attraction. Itong attraction or bonding na ito happens within or inside a molecule. We learned about the polar and nonpolar bond and ionic bond na nangyayari involving the atoms na bumubuo sa tinatawag natin na molecule. So to make it more simple, itong intramolecular forces of attraction is a force that holds the atoms together, and when the atoms are combined together, they are called molecule. So today, ang pag-uusapan natin is the intermolecular forces of attraction. Same concept pa din sa intramolecular forces of attraction, pero mas malawak na ang scope nito. Attractions of molecules to molecules. Attractions of molecules to molecules na ang tinutukoy natin dito. Intermolecular forces of attraction, sa madaling salita, is a force that holds molecules to molecules naman together. And when molecules are together, they are called molecular compounds. What we also need to realize today is that there are different types of intermolecular forces of attraction. They have an arrangement from strongest to weakest, and intermolecular forces of attraction affects the physical properties of molecular or covalent compounds, which includes boiling point, melting point, vapor pressure, and many more. Let's begin with the general types of intermolecular forces of attraction. We have van der Waals forces, ion-dipole interaction, and H-bonding. Under the van der Waals forces, we have dipole-dipole interaction, dipole-induced dipole interaction, and London dispersion forces or London forces of attraction. So here we can see the arrangements of these intermolecular forces of attraction. The strongest among these forces is the ion-dipole interaction. Second to the strongest is the H-bonding. Next is the dipole-dipole interaction. Fourth is the dipole-induced dipole interaction. At ang pinakamahina sa lahat ay ang London dispersion forces. Ngayon, let's proceed with the different physical properties of substances and then i-relate natin siya sa intermolecular forces of attraction na sinasabi natin. First is boiling point. So sabi dito, boiling point is a temperature at which the vapor pressure and atmospheric pressure of a liquid substance are equal. So malinaw, we are talking about liquids. Let's take water as an example. The strength of intermolecular forces of attraction between molecules of water is not that high kasi kaya itong ipag-separate or hatiin easily. Medyo loose ang attraction, kumbaga. So, kung ganito ang attraction meron sa liquid, the more na mabilis itong magbo-boil dahil magse-separate agad ang molecules nito. After that, it will vaporize and turn into a gas. So meaning, the more na mas loose ang intermolecular forces of attraction na meron sa certain liquid, the more na madaling marating ang boiling point nito. That explains yung nakalagay dito sa PowerPoint natin na as the strength of intermolecular forces increases, the boiling point increases as well. Next, we have the melting point. Melting point, by definition, is a temperature at which solid becomes liquid. At this point, the solid and liquid phases exist in equilibrium. The strength of intermolecular forces of attraction between the molecules of solid is higher than that of molecules of liquid. Mas dikit-dikit ang molecules ng isang solid na substance. Ibig sabihin, mas mahigpit yung kapit nila sa isa't isa. Kung imemelt natin ang isang solid na substance, kailangang matibag natin ang intermolecular forces of attraction ng mga molecules nito. Ibig sabihin, the more na mas mataas ang intermolecular forces of attraction meron ang isang solid, mas lalaki naman ang melting point na kailangan nating abutin. Tulad nga ng nakalagay sa ating PowerPoint, as the strength of intermolecular forces increases, the melting point increases as well. Another physical property is the surface tension. Surface tension is an amount of energy needed to increase the surface area of a liquid. Ang positive at negative particles ng molecules sa surface ng isang liquid substance ay attracted sa isa't isa. This scenario makes the forces of attraction in liquid substance tighter doon sa surface nito. Ayun ang tinatawag natin na surface tension. So meaning, the more na mataas ang strength ng intermolecular forces of attraction sa surface ng liquid substance, mas malaki ang surface tension nito. Okay, so next we have vapor pressure. Vapor pressure is pressure exerted by a substance in its gaseous state. It increases with temperature. Let's give an example. Suppose meron tayong liquid. Nasabi natin kanina na ang strength ng intermolecular forces of attraction na meron sa liquid ay medyo loose o hindi ganun kalakas. And kanina, nung napag-usapan natin yung boiling point, nasabi natin na mas mabilis magbo-boil ang liquid na merong mas mahinang strength ng intermolecular forces of attraction. Kapag ang liquid ay inexpose sa high temperature intended to boil it, nagkakaroon tayo doon ng vapor pressure. Ano nga ulit yung vapor pressure? Ito yung pressure na ina-exert ng mga gas molecules. Mas mataas na temperature, mas tumataas yung vapor pressure dahil mas dumadami yung gas molecules. Given that observable knowledge, masasabi natin na kapag mataas ang intermolecular force of attraction na meron sa isang substance, mas mahina ang vapor pressure dahil mas kaunti ang gas molecules na present dito. On the other hand, the more na humihina ang intermolecular forces ng isang substance, the more na tumataas ang vapor pressure dahil mas tumadami ang gas molecules dito. Last in our list is the volatility. Volatility measures the rate at which a substance vaporizes or changes from liquid to gas. Same concept kanina. Kung ang vapor pressure ay ang pressure exerted by the gas molecules, ang tinitignan naman natin dito sa volatility is yung bilis ng isang substance na mag-turn into gas. Given that scenario earlier about boiling, so habang tumataas ang temperature, mas mabilis nating maboboil ang liquid na merong weaker strength of intermolecular forces of attraction compared to a solid substance. Then, it will eventually turn into gas. Sa madaling salita, mas weak ang intermolecular forces of attraction na present sa isang substance, mas volatile ito. Sa kabilang banda, mas mataas ang strength ng molecular forces of attraction present sa isang liquid substance, mas mababa ang volatility nito. Ngayon, alam na natin kung ano ang intermolecular forces of attraction or ang IMFA. We get familiar with its general types, which we will be discussing further next meeting. And lastly, we now know the effects of intermolecular forces on different properties of substance. So that's all for our discussion. See you next week.